Hello my dear students and welcome to Zenith Academy Online. My name is Shagufta Jaipuri and finally we are on the last part of the chapter Electrolysis for ICSE class 10. And in this part we will study the applications of electrolysis, and under this heading we will study three processes, that is electroplating, electrorefining and electrometallurgy. So let's go ahead and understand all these three processes in detail. So first, let's understand what is electroplating. So now let's begin with the definition of electroplating. So electroplating is the electrolytic process of deposition of a superior metal, example nickel, silver, chromium, gold, etc. on the surface of a baser metal or article like iron, copper, brass. Now what does it mean? It is the electrolytic. Electrolytic means, lytic means breaking and electro refers to electricity. So whenever there is breaking happening with the help of electricity, it is known as electrolytic process. Okay. So we understood that there is electricity passing and there is some breaking. Okay. So now when this electrolytic process happens, then what happens? Deposition of a superior metal. So some metal which is superior gets deposited. Where it gets deposited? On the surface of a baser metal. So there is a base metal or an article on which the superior metal is deposited. Let us understand what electroplating is. In electroplating, both an anode and a cathode are immersed in an electrolytic bath. So this is an electrolytic bath in which what two things are immersed? A cathode and an anode. So what is cathode? The electrode which is attached to the negative terminal of the battery is cathode, and electrode which is attached to the positive terminal of the battery is known as anode. Okay. So this is an electrolytic bath in which a cathode and anode are dipped. And what is cathode? The metal part which is to be coated. Okay. So here you can see there is a nail and we want to coat that nail. So wherever we want to coat something, that article is made cathode. Okay. So electroplating, in electroplating both the anode and cathode are immersed in electrolytic bath, and electrolytic bath is composed of a solution of salts including the metal to be plated. Now suppose we want to plate this nail with nickel. So the solution has salt which should contain which metal? Nickel, and this anode should also be made up of nickel. So cathode is made up of the particle which is to be electroplated, and anode is made up of that metal which has to be deposited here, and the electrolytic solution should have the ions of this metal which is to be deposited. Okay. Now a direct current, that is DC, direct current of electricity is passed through the solution, affecting the transfer of metal ions into the cathodic surface, plating the metal onto the item. Now here you can see this battery provides direct current and not alternating current. So a direct current has to be provided, so the metal ions goes towards the cathode and gets deposited here. You will understand this process very well with the help of examples. So before going into the examples, first we should know that what are the reasons for electroplating, why we need to do electroplating. So first reason is it prevents corrosion or rusting of base metal. For example, iron. Okay. So iron gets corroded very quickly. So to prevent iron from getting corroded, it is electroplated with nickel or chromium. So the first reason is protection from corrosion. Second is it makes the article attractive. So if you have a statue of brass, for example, and you want to make it attractive, you can electroplate it with either silver or gold. So the second reason is to make the article attractive. There are certain points which you should remember. First, the article to be electroplated is always placed at the cathode. So you can see this is the negative terminal of the battery and we want to plate this nail. That is why we have placed it at the cathode, because here you can see this is negative terminal. The metal gets discharged at cathode by gaining electrons. This has more number of electrons, it is negative. So the metal ions will move towards negative electrode. Okay, they will accept the electrons and gets deposited there in the form of neutral metal atom. So the nickel ions from the solution will go to the nail and will get deposit there by accepting electrons. So always remember, the article which is to be electroplated is always placed at cathode. The metal to be plated on the article is always made anode. It has to be replaced periodically. Anode is made up of the metal which we want to electroplate on this article. Okay. Now since this metal anode, okay, gets on dissolving, so as we are passing electricity, what happens, this metal gets on dissolving and forms iron. So since it is dissolving, so periodically it has to be replaced because it keeps on getting thinner and thinner as the metal is converting into iron and is going into the solution. So it is getting thinner, that's why we have to replace it periodically. Then the electrolyte must contain the ions of the metal used for plating on the article. I already told you, electrolyte should contain ions of the metal which we want to electroplate on this. A low current and for a longer time must be used. Now this current that we are passing should be low in magnitude, it should be lower in magnitude and should be passed for a prolonged period of time. Now why these two things are very important? Because higher current causes uneven deposition. Because if you pass a high amount of current here, okay, then what will happen? The electrolyte will dissociate very quickly, ions will be discharged very quickly from here. So it will go very quickly towards the cathode and gets deposited unevenly. Okay. Whereas low current for a longer time initiates smooth, firm, uniform and long lasting deposition. That is why you have to pass lower magnitude current and for a prolonged period of time, so that the deposition is very even. The next point that you should remember always while doing electroplating is a direct current, that is DC, and not alternating current should be used. Now students, you know the nature of alternating current, okay. So it keeps on changing direction. So for half cycle it is positive, for half it is negative. So if you would have placed an alternating current here instead of this direct current, what would happen? For half cycle this is negative, for the next cycle this cathode becomes positive. So the metal will first get deposited and then again get ionized if it becomes positive, right? So AC current causes discharge and ionization to alternate at the cathode, thus giving no effective coating. So first it will get deposited, in the second half it will again get ionized and go in the solution. So there will be no effective coating. So that is the reason we should always use direct current, okay, which is provided by a cell or a battery, and never use an alternating current which is provided by the mains of our electricity at our houses. Now electroplating with nickel. So let us study electroplating by taking this example. Now here you can see this is negative terminal of battery, this is positive. So this nail is at cathode and this is nickel, pure nickel metal is made as anode. So we have taken a metal rod of nickel. And what is the solution electrolyte? It is nickel sulfate solution, that is the electrolyte. So what we will do is we will take nickel sulfate, and when electricity is passed through nickel sulfate, it will form nickel ions, which is Ni2 plus, and sulfate ions. Now since it is an aqueous solution, so water will also be there in the electrolyte. It will also form H plus and OH minus ions. Right. Now let's see what happens at cathode. What are the reactions that are happening at cathode? Now this is the cathode. So we know cathode is negative. So all the positive ions will migrate towards cathode. So which are the positive ions you can see in the electrolyte? Nickel and hydrogen. Both of them will migrate towards it, but which will get deposited? Nickel, because it is lower in the electrochemical series. So at cathode what happens? Nickel 2 plus is migrating there, it is accepting 2 electrons and getting converted into nickel atom. Okay, so this is neutral nickel atom which will get deposited on this nail. Okay, it will keep on getting deposited on this nail. Now what happens at anode? Okay, at anode the negative ions should migrate, right? So both of them migrate towards the anode, but none of them gets discharged. Why? Because this anode is nickel, okay, and this is an active electrode. I have already explained you what is active electrode and what happens there. So in the active electrode, none of these ions gets discharged, but the electrode itself takes part in the chemical reaction. So this is nickel, okay, this is the nickel anode. So what it does, it loses 2 electrons to form nickel ions, okay, or you can say that this nickel atom produces nickel ions and electrons, okay, and the same electrons are then taken by this, okay. So now nickel ions are formed. So these ions from here goes into the electrolyte. So here nickel ions are there in the electrolyte. So it will keep on refilling the nickel ions which were lost from the electrolyte and got deposited here. Okay, so the amount of nickel ions remains constant in the electrolyte, okay, because the number of nickel ions that were getting discharged here are again refilled from here, right? So now if it is asked what is formed at anode, okay, what is formed is anode, which products are formed at anode? No products are formed at anode, only this nickel ions are being formed at anode. Okay. So the product formed at cathode is nickel metal, and the product formed at anode is, you can write there are no products formed, or so it is nil, or you can say that nickel ions goes into the solution from anode, right? Also you should remember that this nickel metal is continuously giving out nickel ions, so this reduces in mass. So as the process goes on, this keeps on becoming thinner and thinner, and a uniform coating of nickel is formed over here. So we have to replace this periodically to keep the process going on. So now let's study the electroplating with silver. Now we have taken a similar electrolytic cell. Now at cathode, okay, what we have taken? We have taken a spoon, okay, which we want to electroplate with which metal? With silver. That is why silver is made as anode, okay. The electrolyte solution should also be a salt of silver. So we have taken this salt, sodium argentocyanide solution, okay. This is a complex, okay. So now let us see how electrolysis happens here. So first let's dissociate the electrolyte. So sodium argentocyanide is your electrolyte, okay, and water is also there because it is aqueous solution, right? So first we will dissociate it. Now whenever a complex material, okay, whenever a complex is broken down, this square bracket, okay, is the ligand. So this is one ion and sodium is another ion. So if sodium is +1, okay, this full will have -1. So AgCN2 will be minus, and this soon dissociates again to form silver ion Ag plus and cyanide ion. So there are 2 Cn minus ions, okay. So now we have 2 positive ions, okay, from this, and when water breaks up it forms H plus and OH minus, right? Now let us see what happens at cathode. Now at cathode the positive ions will migrate because cathode is negative. So which are the positive ions? H plus, Na plus and Ag plus. So out of all 3 of them, Ag plus is the lowest in the electrochemical series, so this will get discharged. So this Ag plus will accept one electron and form silver metal, neutral silver metal atom. So this is atom of silver which keeps on depositing on the spoon. Okay. Now what happens at anode? At anode the negative ions should go. So which are the negative ions? OH minus and Cn minus ions. So they will migrate, but none of them will get discharged because again this is an active electrode. So active electrode takes part in the electrochemical reaction itself. So now this silver metal atom which is there in anode, okay, what happens? They form the ions and loses the electron. So you can either write one electron here or you can subtract one electron here. Okay. So at cathode what you are getting? Silver, deposition of silver. At anode what is happening? This silver metal atom is converting into ions and these ions are getting in the solution. So it keeps on decreasing in mass and that is why it has to be replaced periodically. So that was all about electroplating with silver. Now there is a very frequently asked question that why sodium argentocyanide is preferred to AgNO3. So we have been studying that AgNO3 easily dissociates to form Ag plus and NO3 minus, right? So easily we are getting Ag plus ions, then why are we not using this as an electrolyte and why are we using sodium argentocyanide? Okay. Now the reason is sodium silver cyanide is preferred to silver nitrate as an electrolyte. Why? For electroplating of an article with silver, because deposition of silver ion is slow. In which case, in sodium argentocyanide the deposition of silver ions is slow and smooth, and that is why the coating is smooth, whereas this dissociates very quickly to give silver. Okay. Whereas the migration of ion in silver nitrate is rapid, and that is why it causes uneven deposition, and we don't want uneven deposition, right? We want a uniform and smooth deposition, which is possible here because of sodium argentocyanide. That is why we prefer this over AgNO3. So that is a very good question that can be asked in your exam. Now let's go ahead and learn the second process, that is electrorefining. The word itself tells us many things, that it is refining, that is purification with the help of electricity, electrorefining. Electrorefining is a process by which metals containing impurities are purified. How they are purified? Electrolytically, to give a pure metal. So the term refining means to make pure, and electro means the method employed to make the metal pure, that is by electrolysis. Now let us study the basic example of electrorefining, that is electrorefining of copper. Now here you can see the electrolytic cell has copper sulfate solution. So even in electrorefining, the solution, that is the electrolyte, should contain a salt which has the ions of the metal which we want to purify in this case. So in this case we are doing for copper, we want to refine copper. So we are using copper sulfate salt so that there are copper ions and sulfate ions. Okay, so we wish for copper ions, that is why we have taken a salt like copper sulfate. Now we want to purify this metal rod. Okay, so this is a thick rod of impure metal which we want to purify. So this impure metal is kept at anode. Okay, it is connected to the positive terminal of the battery, and pure metal is made cathode, that is connected to the negative terminal of the battery. Okay, so remember these things very well. Impure metal which we want to purify is kept at anode, and pure metal is kept as cathode. Okay, so very thin film of pure metal is taken. Okay, now what happens when the current is passed? Okay, this copper sulfate solution dissociates and form copper ions and sulfate ions. Okay, since it is aqueous, so water will be also there, H plus and OH minus. Now let us see what happens at cathode. So cathode, okay, now so what is cathode? Cathode is pure metal and it is attached to negative terminal. So towards the negative terminal, which ions will come? The positive ions will come. So which are the positive ions? Copper and H plus. So out of copper and H plus, which will get discharged? Obviously copper, because it is lower in the electrochemical series. So copper 2 plus ions from the solution will come towards cathode. It will accept 2 electrons because it is a negative terminal, so it will gain 2 electrons from here and it will form copper metal atom. So this is the neutral atom which gets deposited. So it keeps on getting deposited here. So it is in the purest form. Okay. Now let's see what happens at anode. Okay. Now anode is also an active electrode. So impure metal. Okay. Now this copper has many impurities in it. I will tell you which impurities there are along with this, okay, in the coming slide. So let us see the anode. What happens at anode? Copper at metal, okay, loses electrons to form copper ions. Now you can see here there are other negative ions also. They migrate towards anode but do not get discharged because this is an active electrode. So copper itself is taking part, it is losing electrons and forming copper ions, and these copper ions again come back to the solution. That is why the solution always remains blue, okay, because earlier from the solution the copper ions went towards the cathode and got deposited, but it was replenished again from anode. So the concentration of copper ions remains constant. Now as soon as we see in the electrolysis that the blue color of the solution is getting faded, then we come to know that there are less copper ions, and also we see that this anode, okay, keeps on becoming very less, keeps on reducing in mass. So then we will replace it. Okay. So now what is happening at anode? These copper ions are getting discharged, they are going out in the solution. So this keeps on decreasing in mass. So the product formed here at anode, we can say there are nil products formed, and here there is copper metal form. So as soon as we see that the blue color is getting faded, so what is happening? That copper ions are getting lesser. So we should change the impure metal rod, or we should change the copper sulfate solution. Now, so as the reaction proceeds, this goes on increasing in width, this goes on getting bigger and bigger, and this goes on getting smaller and smaller. So the impurities which were there in this copper now will fall down and get deposited down like anode mud. This is known as anode mud, or it is also known as slime. So there are certain impurities which are insoluble. So these insoluble impurities will form anode mud, whereas there are certain impurities which are soluble, okay, which will ionize and gets soluble in this mixture, okay, electrolytic solution. Let's see which impurities are there. So the impurities present in the impure copper anode settle down as anode mud or slime, as I told you. Now this contains insoluble impurities, okay. So the ones which will deposit below anode, that is anode mud, which will contain insoluble impurities like gold and silver. You have to remember the names. Gold and silver are insoluble impurities which are present in copper anode. Now the impurities such as iron, zinc, etc., which are higher in the electrochemical series, ionize and dissolve in the electrolytic copper sulfate solution. So iron and zinc are the soluble impurities which are higher in the electrochemical series, they ionize and dissolve in the electrolytic solution. Now, if we talk about the refining of copper on an industrial level, we will not do it in one cell, okay, we will not do one rod separately. So, what happens here, see here there are plates, so there are parallel plates. So, this cathode you see, can you see this cathode? Okay, these are all pure copper, okay, which is containing a very high purity, say 99.99% of pure copper, and these anode consist of these anodes, okay, these anodes consist of impure copper, okay. Now it is also known as blister copper anode, okay. Why is it called blister? Because we know what happens at anode, the metal, okay, converts into ions and goes in the solution. So the metal keeps on losing, so on the surface it feels like there are blisters on the skin. So have you seen any times when you get burnt, okay, then there are blisters which appear on your skin. So this also looks like blisters on the rod, so that is why it is known as blister copper anode. And below anode you can see there is anode slime or anode mud, okay. So below each anode there are this anode slime. So these parallel plates are dipped in the copper sulfate solution and simultaneous refining happens at a larger scale. Here you can see the real picture of an industry. So there are these parallel plates which are dipped in the electrolytic solution and they are getting refined at a higher rate simultaneously. Now these are the frequently asked questions. Which metals are refined by electrolysis? The highly electropositive metals like zinc, lead, copper, mercury and silver, okay. So you should remember these names, few names. Now one very important thing to note here is these metals are already deposited at the cathode in pure state and hence need not be refined further. So in our coming lectures we will be talking about the chapter metallurgy. In that you will study in detail that how you take out a metal from an ore and finally how you purify it. So how to extract metal is that study is known as metallurgy, and in metallurgy we study that in the last stage we refine it. So here there is no need for the refining step, because here whatever metal we are getting is already in the pure state. So now coming up on electrometallurgy. So as I told you, there will be a complete full chapter on metallurgy. So electrometallurgy is a part of that chapter, okay, and it finds application in electrolysis. That is why we are studying it here. So what is electrometallurgy? It is a method in metallurgy that uses electrical energy. Electro part is using of electrical energy to produce metals by electrolysis. So metallurgy is obtaining metals and electrometallurgy is using electrical energy to produce metals, okay. So now it is usually the last stage in the metal production, okay. So if we see here, this is an electrochemical series, okay. Now the metals which are lower in the electrochemical series, okay, they are extracted by thermal decomposition, okay. Now since they are very unstable, they form very unstable compounds, okay, they are least reactive ones. So the compounds are also unstable, so their oxides are least stable and heat alone can reduce these metallic oxides to metal. So we want to extract metal from the oxide. So for example, there is this mercury oxide. So when it is heated, it forms mercury metal and oxygen. So we get the metal, okay. So here by heating only we can get. Now the elements which are in the middle of the series, we can use reducing agents like carbon monoxide and hydrogen to obtain the metal from their metallic oxides, okay. So their oxides are less stable, okay, and reducing agents can reduce metallic oxide to metal. So heating alone will not help, we will use some reducing agents to form these metals, okay. So this is all part of metallurgy. Now let us study how electrometallurgy comes into picture. So these elements which are higher in the electrochemical series, okay, they can be obtained from their fused salts only by using electrolysis. Okay, so here the study of extraction of these metals is electrometallurgy. So for metals higher in the electrochemical series, we use electrolysis. Why we use electrolysis? Because their oxides are highly stable. Heating and using the reducing agent will not help us to obtain the metal. Okay, here to obtain metal we will have to pass electricity through it, in their fused salts. So their oxides are highly stable. Metal has strong affinity for oxygen. So metal, since they are highly electropositive, more electropositive, and we know oxygen is highly electronegative, so the bond that is formed in between them is very strong. So by heating we cannot break that bond, by using reducing agents also we can't break that bond. So to break that bond and obtain only metal, what we can do? We can do electrolysis. We can use electrolysis, okay, that is we can pass electricity through its molten salt. So on electrolysis the metal is deposited at cathode. Now let us see how these metals can be obtained now. So metals generally extracted by electrolysis are potassium, sodium, calcium, magnesium and aluminium. You should learn these names, that these metals can be extracted by electrolysis. Okay, so let us see these three examples. First let's see fused sodium chloride, how it is extracted. If you see NaCl, okay, and if you melt it, if you fuse it, okay, you get the ions Na plus and Cl minus. So let us see what happens at cathode. So since cathode is negative, so positive ions will go there. So this Na plus will go there, accept one electron and forms sodium atom. So sodium metal atom is formed, which will get deposited at cathode and we will get the metal in the pure state. Now at anode what is happening? At anode the negative ion will go, okay, so this chlorine will give out one electron and will form chlorine atom. Now two such atoms will combine to form a chlorine molecule. So chlorine gas is evolved at anode. Okay, so at cathode what you are getting? Metal is getting deposited. That is why we are able to extract sodium from NaCl. And at anode chlorine gas is released. Now let us see what happens with fused calcium chloride. So calcium chloride is CaCl2. So when electricity is passed through it, it forms calcium ions and chloride ions. So there will be two chloride ions formed here. Now what will happen at cathode? So at cathode positive will go. So this calcium 2 plus will go and accept two electrons and form calcium metal atom and will get deposited here. So we will be able to extract calcium from calcium chloride. And at anode what happens is this goes obviously. So two chlorine atoms will lose two electrons, one each, okay, and form, basically it will form two chlorine atoms which will get converted into chlorine molecule. Okay, now what happens to fused alumina? Now alumina is Al2O3. When it dissociates, okay, in presence of current, then aluminium 3 plus and oxide. Now, oxide is 2 minus, so there will be 3 oxygen and there will be 2 aluminium ions. Okay, now at cathode the positive will go. So if we take 2 aluminium 3 plus, okay, so there are total how many positive charges? 3 plus, and there are 2 3 plus, so it is 6. So it will accept 6 electrons and form 2 aluminium atoms and it will get deposited there. Okay, now what happens at anode? This oxygen 3O minus, okay, goes and loses 6 electrons. It is losing 6 electrons and it is forming 3 oxygen atoms. Now these are nascent oxygen atoms, correct? So 3 oxygen atoms plus 3 oxygen atoms combined to give 3 molecules of oxygen gas. So this oxygen gas is released at anode and at cathode we get a metal. So this is how, by using electrolysis, that is performing electrometallurgy, we get the metals from their fused salts. So that was all the 3 applications of electrolysis. I hope you enjoyed the lecture and understood each and every concept very well. And I have covered each and everything from the textbook and nothing has been left. So when you are watching the video, try to make your own notes, pause the video in between, make your own notes and ace the examination. So if you have liked our video, please give it a thumbs up and write in the comment section below. It encourages and motivates me to make more and more videos for you. Also, keep the learning on by sharing my videos with all of your friends and enjoy learning at Zenith Academy Online. Thank you.